Now we're going to solve a linear equation using the intersection method. And once we go over this example, we're actually going to go back to example 1 and verify our answer in our calculator for the one that we did by hand. So you have two steps here when solving linear equation using the intersection method, and we're going to be using this quite a bit. I would say when we're talking about linear equations or functions, we're mostly going to do those by hand. But once we get into quadratics and cubics and all kinds of other functions, intersection method is going to be very, very useful. So first thing we need to do is enter the left side of the equation as our y1 and the right side of our equation as our y2. So this left side here is y1. And then our right side here is our y2. We want to graph both of these equations on a window that shows their point of intersection. So if I can't see their intersection, I'm going to have to mess around with that window some. Okay, so y equals, clear everything out. My y1 is going to be this right here. Now you do have to be careful when you type these in. When we are typing this in, we're going to use our fraction key. And so here's our instructions on how to type in a fraction on our calculator. Okay, so we're going to hit alpha y equals, and then it's the first one, number 1, n over d, which is our numerator over denominator. So pause the video if you need to copy that down. Okay, so we're going to go alpha, which is the one under your second, alpha y equals, and then that very first one, n over d, is the one we want. If you have a TI 83, you can't do this. So I would recommend either buying one or renting one from the math lab, or I guess now what's it called? The Learning Hub, the Math Resource Center, something like that. I don't know. Check Moodle, you can find the link. But you need an 84 for that n over d option. Okay, and I'm going to type in x, even though it's y, that's just a variable. We can change the variable to be anything we want. So I'm going to type in x. So we have 2x minus 3 all over 4. And I'm going to arrow over, or I'm just going to arrow down. I'm going to use that n over d again here. So alpha y equals n over d. Now we have x over 3 and then arrow over plus 1. Okay, so I have typed this into my calculator. And I'm just going to do a zoom 6. We're going to try a standard. So number 6 for a standard, since I don't know what the solution is. Okay, there's my first one. And here is my second one. So they might be intersecting right there at the very edge, but let's just go ahead and expand that out a little bit, because I do need to make sure that their point of intersection is in my window. So if they might be a little bit more over here, what would I need to expand? I need to go further this way. I need to expand my X max. So let's go over here to window. And instead of 10, we could do 15. I'm just going to do 20 just to be safe, but 15 would probably work. So I'm going to change that to 20 and now regraph it. And what I'm needing to see is my intersection. All right, so I can see that they are crossing right around here somewhere. So now let's find that intersection. Now it tells you what to do here. It says, find the point of intersection with the intersection command after pressing second trace. This is the point where our y1 equals our y2. Let's actually highlight this. The x value of this point is the value that makes the two sides of the equation equal. So it is the solution to the original problem. Let's just highlight that whole thing there. Okay. Keyword, that x value. Okay, so down here, let's find that intersection, which I kind of talked about with doing the pressing second trace, but a little bit more specific. So we're going to go to calc, which is second trace. We have already used, have we used 0 in this class? I don't know. We might have used 0. I kind of think we have, but if we haven't, we will. We have definitely used min and max, but now I want the intersection. So number 5 intersects. We either arrow down or just press 5 and then hit enter 3 times because there's only one intersection and only 2 lines. I'm on the first curve, enter. I'm on the second curve, enter. Always enter through guess. And there is my intersection point. A little bit, there we go, a little bit more clear. Okay, so we get x equals 10.5 and we have y equals 9/2. Don't know why one's a fraction and one's a decimal, but we highlighted up at the top. It's that x value we're talking about. So my solution here would be x. Now that's a little confusing because on this one, our variable was y, but we changed that y to an x. Okay, so let's try really quickly to do this on our first example that we did. So instead of using all of this space and doing all of this work, let's try the same method here. So I am going to put this left side as my y1. And let's just change colors. And this right side as my y2. So clear everything out. Use your fraction key. So alpha y equals n/d. We have 5 parentheses x minus 3 on the bottom 6, arrow over minus x. And then 1 minus alpha y equals n/d x/9. Oops. x/9. Okay, and if I just happen to hit graph, I'm not going to get that intersection point. With this one, we knew what the solution was. It was -63. And so I just want to kind of reiterate again. We need that intersection. So if I can't see that intersection, I need to move this some way. And because we're checking, we know it's -63. I'm going to go into this window here and then change my y min to maybe a -70. And we should hopefully see our intersection. Just barely, but we got there. Okay, you can kind of tell specifically because my calculator has the different colors that that red is just slightly below and now it's on the top. Okay, so I'm going to go to calc here. So second trace, number 5, enter, enter, enter. And we get that x equals -63 right there, which we got when we did this by hand.